When people start learning about machine learning, a common assumption forms very quickly that machine learning is always the best solution if you have enough data, enough computing power, and a powerful model. Then machine learning must be the answer. But in real-world systems, this assumption actually causes more failures than successes. Machine learning is powerful, yes, but it is not universally appropriate. In fact, many production problems are better solved without machine learning at all. The first question you should ask before reaching for machine learning is not which model should I use. The real question is, do I even need machine learning at all? If a problem can be solved using a simple, deterministic rule, then a rule-based system is usually the better choice. Rules are easier to understand, easier to debug, easier to test, and much easier to maintain. For example, think about converting a zip code to a state, checking if a password meets length requirements, or validating a form field. These problems do not benefit from machine learning. Using machine learning in these cases would only introduce unnecessary complexity. Machine learning systems require data pipelines, constant monitoring, retraining, and careful handling of failure cases. If a simple rule works reliably, then adding machine learning just adds cost without adding any real value. Machine learning becomes useful when those simple rules start to break down, when the patterns are too complex to describe explicitly, for example, predicting user behavior, recognizing images or speech, detecting complex fraud, or recommending content. In these scenarios, the relationships between the inputs and the outputs just can't be captured with simple logic. Another critical requirement is data. Machine learning systems learn patterns from historical data. If you don't have enough data, or if the data you have is noisy, biased, or incomplete, machine learning won't magically solve your problem. In fact, it often makes the problem worse by hiding errors behind its predictions. Then there's the question of cost. Let's be real. Machine learning systems are expensive. They require significant compute resources, engineering time, monitoring infrastructure, and long-term maintenance. If the business impact of the prediction is small, the cost of implementing and maintaining a machine learning solution might completely outweigh its benefits. Another common mistake is using machine learning for problems that cannot tolerate any errors. Machine learning systems are probabilistic by nature. They will make mistakes. If a system requires perfect correctness, like in legal decisions, financial guarantees, or safety-critical operations, then machine learning is probably the wrong tool for the job. At its core, machine learning is about prediction. It's not about reasoning. It's not about understanding. And it's not about decision-making by itself. If your problem cannot be framed as predicting an outcome based on input data, then machine learning is likely not the right approach. This is exactly why experienced machine learning engineers often start with the simplest possible solution. They begin with rules, heuristics, or basic statistical methods. Only when these simpler approaches fail do they consider introducing machine learning. Choosing not to use machine learning is not a sign of weakness. It's a sign of good system design. Real-world machine learning isn't about using it everywhere. It's about using it only where it creates real, measurable value. Understanding when not to use machine learning is one of the most important skills in designing production-ready systems. It separates the hobbyists from the professionals. Thanks for watching. If you found this helpful, be sure to like and subscribe for more content on practical machine learning.